Good day everyone! Welcome to Mathfinity, where math learning is fun and exciting. For this new episode, I will teach you how to perform division of polynomials using long division and synthetic division. That is presented in the most essential learning competency number 8 in Mathematics 10. Before we divide polynomials, you must remember division algorithm. Division algorithm states that for any polynomial function p of x and d of x, there exists a unique polynomial function q of x and or such that p of x is equal to q of x times d of x plus or that is the same as dividend p of x is equal to the product of the quotient q of x multiplied by the divisor d of x added by the remainder. Let's now consider dividing a third-degree polynomial by a first-degree polynomial. In able for you to divide this correctly, you must employ the following steps. First, arrange the dividend and the divisor in standard form. If there are missing terms, write them with a coefficient of 0. When do we say that a polynomial is already arranged in standard form? A polynomial is said to be arranged in standard form when the degrees of each term are arranged in descending order. That means this dividend is not yet arranged in standard form since the degree of each term is not yet arranged in descending manner. So enable for us to do the first step, we will write the dividend in standard form. That is 3x cubed plus 16x squared plus 19x minus 10. The divisor is already arranged in standard form. So that must be 3x cubed plus 16x squared plus 19x minus 10 divided by x plus 3. We are already done with the first step. The second step is to divide the first term of the dividend by the first term of the divisor, or the leading term of the dividend divided by the leading term of the divisor. The leading term of our dividend is 3x cubed, and the leading term of the divisor is x. So we will divide 3x cubed divided by x. So that will be 3x cubed divided by x. By laws of exponents, we know that the quotient of 3x cubed divided by x is 3x squared. But in able for us to easily understand this, we can write 3x cubed as factors of 3 times x times x times x divided by x. We can cancel out one pair of x, and what will remain is the product of 3 x and x, and that will be 3x squared. So therefore, 3x cubed divided by x is equal to 3x squared. The next step is to multiply the result in step 2 by our divisor. That is 3x squared times x plus 3. So find the product of 3x squared and x plus 3. By distributive property, 3x squared times x is equal to 3x cubed. 3x squared multiplied by positive 3, that is plus 9x squared or positive 9x squared. And the result will be written under our dividend. That is 3x cubed plus 9x squared. The fourth step is subtract the result from step 3. That is 3x cubed plus 16x squared plus 19x minus 10 subtracted by the result. That is 3x cubed minus 3x cubed, that is 0x cubed. 16x squared minus 9x squared is 7x squared. Since this term has the coefficient of 0 and we know the product of 0 times x cubed is 0, you can just simply omit this term. And what will remain is positive 7x squared. So we will bring down 19x. Then, we will repeat the process until the remainder is 0 or its degree is less than of its divisor. So we will repeat the process. 7x squared, which is the leading term, divided by the leading term of our divisor, that is 7x squared divided by x. And we know that 7x squared divided by x is just simply 7x. Because 7x squared can be written as 7 times x divided by x. So we can cancel again pair of x. And what will remain is the product of 7 and x. So, the quotient of 7x squared and x is 7x. Then, we multiply the result 7x by our divisor. 7x times x plus 3. That is 7x multiplied by x plus 3. By distributive property, 7x times x is 7x squared. 7x times 3 is positive 21x. Then, write again the result. 7x squared plus 21x. What will be done next? Subtract. 7x squared minus 7x squared is 0. 19x minus 21x is negative 2x. Then, bring down negative 10. Negative 2x minus 10, or we will repeat the process. Negative 2x divided by x, that is simply as negative 2. Because negative 2x divided by x can be written as negative 2 times x divided by x. So, what will remain is negative 2. So, negative 2. Negative 2 again multiplied by our divisor. Negative 2 times x plus 3. It's negative 2 multiplied by x plus 3. By distributive property, negative 2 times x, that's negative 2x. Negative 2 times 3 is negative 6. So, writing the result, negative 2x minus 6. What will be done next? Correct, subtract. Negative 2x minus negative 2x, that will become 0 because this will be changed as positive. Negative 2x, then proceed to addition. Negative 2x plus 2x is 0. Then, negative 10 minus negative 6. Again, this will become positive. Negative 10 plus 6, that is negative 4. So, the remainder is negative 4. So, since the degree of our remainder is 1 less than the divisor, we will now stop continuing the process. So the answer will be 3x squared plus 7x minus 2 with a remainder of negative 4. We will write our final answer as quotient. Quotient is equal to 3x squared plus 7x minus 2 plus the remainder of negative 4 over x plus 3. So as you notice, we write the remainder as negative 4 over the divisor because that is a polynomial expression. So remember, you will write the remainder in terms of the value of the remainder divided by your divisor. That is our answer. 3x squared plus 7x minus 2 plus the quantity of negative 4 over x plus 3 is the quotient when 3x cubed plus 19x minus 10 plus 16x squared is divided by x plus 3. By following the division algorithm, we can write the dividend as the product of the quotient and the divisor added by the remainder of negative 4. That is, dividend, which is 3x cubed plus 16x squared plus 19x minus 10 should be equal to the product of the quotient, which is 3x squared plus 7x minus 2 multiplied by the divisor x plus 3 added by negative 4. That means when you perform and evaluate the right side of this equation, the polynomial must be equal to the original or to the dividend. That's 3x cubed plus 16x squared plus 19x minus 10. Let's now consider illustrative example number 2. States that if p of x is equal to 2x cubed minus 3x squared minus x plus 4 and d of x is equal to x minus 3, find p of x divided by d of x. So in this example, polynomials are expressed as functions. Given that p of x is equal to 2x cubed minus 3x squared minus x plus 4, that will be divided by d of x, which is x minus 3. That just simply means we will divide p of x by d of x. So, since we already know what are the steps in dividing polynomials using long division, we'll now check, or we will now verify and solve for the quotient. That is 2x cubed minus 3x squared minus x plus 4 divided by x minus 3. So, as you can see, the first step is already done because the dividend and the divisor are already written in their respective standard form. So, we must proceed to the second step. That is dividing the leading term of the dividend by the leading term of our divisor. So 2x cubed divided by x. So 2x cubed divided by x, what's the answer? That's just the same as 2x squared. By laws of exponents, that is, this 2x cubed can be written as 2 times x times x times x divided by x. Then, we can cancel out one pair of x, and what will remain is the product of 2 and x, that's 2x squared. So, we have now the first term of the quotient, that is 2x squared. What will be done next? Multiply the result by the divisor, that is 2x squared multiplied by x minus 3. By distributive property, 2x squared times x is equal to 2x cubed. 2x squared times negative 3, that is negative 6x squared. Then write the result under dividend. 2x cubed minus 6x squared. Then subtract. 2x cubed minus 2x cubed is 0x cubed. Negative 3x squared minus negative 6x squared, this will become positive. Then proceed to addition. Negative 3x squared plus 6x squared, the answer is 3x squared. Bring down the next term, that's minus x. Then repeat. 3x squared divided by x, that is 3x squared divided by x by laws of exponent. The answer is just 3x. 3x squared can be written as 3 times x divided by x, cancel one pair of x. The result is the product of 3 and x, which is 3x. So that will be plus 3x. Then multiply 3x times x minus 3. What's the product of 3x and x minus 3? That is 3x multiplied by x minus 3. By distributive property, 3x times x is equal to 3x squared. 3x times negative 3 is negative 9x. Then, write the result. 3x squared minus 9x. Then, subtract. 3x squared minus 3x squared is 0x squared. Negative x minus negative 9x, this will become positive. Negative x plus 9x is 8x. Then bring down positive 4. That will become 8x plus 4. Then, repeat the process. Find the quotient of the leading term, 8x, and the divisor, or the leading term of the divisor, which is x. 8x divided by x is positive 8. Then, find the product of 8 and the divisor. 8 times x minus 3. 8 times x minus 3. By distributive property, 8 times x is equal to 8x. 8 times negative 3 is negative 24. Then write the result. 8x minus 24. Then, subtract. 8x minus 8x is 0, or 0x. Then, 4 minus negative 24, this will become positive. Then proceed to addition. That will become 4 plus 24, that is 28. Since the remainder is 1 less than, or since the remainder has a degree of 1 less than the divisor, we now stop at 28. So the quotient of p of x and d of x is equal to 2x squared plus 3x plus 8 plus 28 over x minus 3. We can now express p of x in terms of the product of the quotient and the dividend added by the remainder. That is, the dividend p of x must be equal to q of x multiplied by d of x added by the remainder. P of x must be 2x cubed minus 3x squared minus x plus 4. That should be equal to the quotient of x, which is 2x squared plus 3x plus 8 multiplied by x minus 3, which is your divisor, added by the remainder, which is 28. I represented the quotient of p of x and d of x as q of x. That is, q of x is equal to p of x divided by d of x. So, we have written the dividend p of x in terms of the quotient, the dividend, and the value of the remainder. We are already done dividing polynomials through long division method. Another method that you can use is synthetic division method. So we will prove that the quotient using the synthetic division method will be the same as the quotient in long division method. So the given in illustrative example 1 was 3x cubed plus 16x squared plus 19x minus 10 divided by x plus 3. Using long division method, we arrive at the quotient of 3x squared plus 7x minus 2 with a remainder of negative 4. And that remainder is expressed as negative 4 over x plus 3. In able for you to divide polynomials correctly, you must remember that the entire process or solution will be consisting of row 1, row 2, and row 3. So step number 1, write the numerical coefficient of the dividend, which must be written in standard form, in the first row of the solution. Insert a 0 for the coefficient of the missing power of x. As you notice, the dividend is already written in standard form. Furthermore, we have no missing terms, or we have no missing power of x in the given dividend. So we will now write the numerical coefficient of each term. The first numerical coefficient is 3. The second numerical coefficient is 16. Third numerical coefficient is 19. And the constant is negative 10. Then, step number 2, express the divisor in the form x minus a. Write the value of a, which is the divisor, on the leftmost entry of the first row. Enable for us to solve for the value of the constant a, we can use the divisor x plus 3, and we will equate that into 0. That's already written in the form of x minus a. Why? X plus 3 is the same as x minus negative 3. So this will be x minus a. So the value of a is negative 3. Or you can just solve for the value of x that is representing the value of a. By equating x plus 3 into 0, then solving for x. In this equation, the solution must be negative 3. So x is equal to negative 3. Therefore, a is equal to negative 3. Third step, bring down the first coefficient on the third row. Multiply the first coefficient by a and write the product on the second row below the second coefficient. That is 3 times negative 3 is negative 9. Fourth step, find the sum of the product and the second coefficient, then write the sum on the third row. Find the sum of 16 and negative 9. 16 plus negative 9 is positive 7. Multiply this sum by a. Add the product to the next coefficient and write again the new sum on the third row, and so on. We will repeat the process. 7 times negative 3 is negative 21. 19 plus negative 21 is negative 2. Negative 2 times negative 3 is positive 6. So, we have done the same process until a product has been added to the final coefficient. So, negative 10 plus 6 is equal to negative 4. The last sum in the third row is representing the remainder. The preceding numbers are the numerical coefficient of the quotient. The quotient is a polynomial of degree 1 less than the degree of the dividend. So, this negative 2 represents the coefficient of the constant. This 7 represents the coefficient of the term degree 1. And this 3 represents the coefficient of degree 2. Therefore, our quotient is equal to 3x squared plus 7x minus 2, that is representing the constant, plus the remainder, negative 4, which is expressed as negative 4 over your divisor, x plus 3. So as you will notice, the quotient in synthetic division is the same as the quotient in long division. That is 3x squared plus 7x minus 2 plus a remainder of negative 4 that is expressed as negative 4 over x plus 3. Let's now verify that the quotient in illustrative example number 2 is the same as the quotient when we use the synthetic division method. Illustrative example number 2 was p of x is equal to 2x cubed minus 3x squared minus x plus 4, that is divided by the d of x, which represents x minus 3. The quotient of p of x and d of x is equal to 2x squared plus 3x plus 8 plus a remainder of 28, which is expressed as 28 over x minus 3. Let's now proceed to the synthetic division. So the dividend are already arranged in standard form. So we will write now the coefficients of the dividend. The coefficients of the dividend are 2, negative 3, negative 1, and positive 4. Then we solve for, then the divisor is already written in x minus a, so we just need to solve for the value of x by equating the divisor x minus 3 into 0. Then solve for x. The solution for this equation is x is equal to positive 3. So, we write 3 at the leftmost corner. Then, proceed to synthetic division. Bring down the first coefficient, that's 2. multiplied by 3, that is 6. Negative 3 plus 6 is positive 3. 3 times 3 is 9. Negative 1 plus 9 is equal to 8. 8 times 3 is equal to 24. 4 plus 24 is equal to 28. Again, the third row represents the numerical coefficient of the quotient. That is, the rightmost number representing the remainder. Next to it is the constant, degree 1, and degree 2. Therefore, we have now the quotient of p of x and d of x as 2x squared plus 3x plus 8 plus a remainder of 28 expressed as 28 over x minus 3. So as you notice, they are just the same. Either of the method can be used. Let's proceed to illustrative example number 3. For this example, we are going to compare the quotient of p of x and d of x through long division and synthetic division. Let's try divide or find the quotient of p of x and d of x using long division. P of x is equal to 4x raised to 4 minus 5x squared plus 8x minus 12, while d of x is equal to 2x minus 3. So, through long division method, first step, ensure that the dividend and the divisor is written in standard form. The dividend, as you can see, is already written in standard form. However, there is one missing power of x. So that one missing power of x could be represented by 0x cubed. So let's now proceed. 4x raised to 4 plus 0x cubed minus 5x squared plus 8x minus 12 divided by 2x minus 3. So we have now written the division sentence. That is 4x raised to 4 plus 0x cubed minus 5x squared plus 8x minus 12 divided by 2x minus 3. So, next step is to divide the leading term of the dividend by the leading term of the divisor. The leading term of the dividend is 4x raised to 4. The leading term of the divisor is 2x. So that is 4x raised to 4 divided by 2x. That is 2x cubed. To show that the quotient is 2x cubed, we can write 4x raised to 4 as 4 times x times x times x times x. And 2x can be written as 2 multiplied by x. We can cancel again one pair of x. What will remain is 4 times x times x times x divided by 2. 4 and 2 has a common factor. We can divide that. 4 divided by 2 is equal to 2. So this will be 2. So 2 times x times x times x by loss of exponents is 2x cubed. So we write 2x cubed on top of the second term. Then, multiply 2x cubed by the divisor. So that's 2x cubed multiplied by 2x minus 3. By distributive property, 2x cubed times 2x is equal to 4x raised to 4. 2x cubed times negative 3 is negative 6x cubed. So write the result below the dividend. 4x raised to 4 minus 6x cubed. Then, what will be done next? Subtract. 4x raised to 4 minus 4x raised to 4 is 0x raised to 4. Then, 0x cubed minus negative 6x cubed. So, the sign will be changed. And proceed to addition. 0x cubed plus 6x cubed is 6x cubed. Bring down the next term of the dividend, that is negative 5x squared. Then, divide again the leading term by the leading term of the divisor. That is 6x cubed divided by 2x, that is 3x squared by laws of exponent. So we can express the same expression as 6 times x times x times x divided by 2 times x. We can cancel one pair of x, and what remains is 6 times x divided by 2. But 6 and 2 has a common factor. So we can divide 6 divided by 2, that is 3. 3 times x is 3x squared. So we write 3x squared above the third term of the dividend. So 3x squared multiplied by 2x minus 3. That is 3x squared multiplied by 2x minus 3. By distributive property, 3x squared times 2x is equal to 6x cubed. 3x squared times negative 3 is negative 9x squared. So we write the result, 6x cubed minus 9x squared. Then, what will be done next? Subtract. 6x cubed minus 6x cubed is 0x cubed. Negative 5x squared minus negative 9x squared is equal to, the sign will be changed. Then proceed to addition. Negative 5x squared plus 9x squared is equal to 4x squared. Then, bring down the next term of the dividend, that is positive 8x. Then continue dividing. 4x squared divided by 2x that is 2x. To show that it is 2x, we can express 4x squared as 4 times x divided by 2 times x. We can cancel one pair of x, and what will remain is 4 times x divided by 2. 4 can be divided by 2. So, 4 divided by 2 is equal to 2. 2 times x is equal to 2x. So, we will now write 2x above the dividend. So, we will now multiply the result 2x by 2x minus 3. By distributive property, 2x times 2x is equal to 4x squared. 2x times negative 3 is negative 6x. Then, subtract. 4x squared minus 4x squared is 0x squared. 8x minus negative 6x, this will become positive. Then proceed to addition. 8x plus 6x is equal to 14x. Then, bring down the last term, that is the constant, negative 12. Then 14x divided by 2x is equal to 7. Positive 7. Then 7 multiplied by 2x. By distributive property, 7 times 2x minus 3 will become 7 times 2x, that is 14x. 7 times negative 3 is negative 21. Then, finally, subtract 14x minus 14x is 0, negative 12 minus negative 21, the sign will be changed. So, become positive. Then, proceed to addition. Negative 12 plus 21 is positive 9. Therefore, we have now the quotient as 2x cubed plus 3x squared plus 2x plus 7 with a remainder of 9. We will now show that the quotient of long division will be or will have the same quotient when we use synthetic division. So, given p of x and d of x such as 4x raised to 4 minus 5x squared plus 8x minus 12, that is to be divided by 2x minus 3. In this particular example, we are dealing with a linear divisor whose leading coefficient is not equal to 1. The leading coefficient of this linear divisor is 2. What we know right now is to divide polynomial by a linear divisor whose leading coefficient is equal to 1. That is in the form of x minus a. What we want is to rewrite this whole expression so that we are dividing with a linear divisor whose coefficient is equal to 1. We can do that by factoring out the divisor in the form of this expression. So we factor out 2 so that we can write the linear divisor in the form of x minus a, in that case, which we have a leading coefficient that is equal to 1. The numerator will not change. We will write this factor of 2 to the outside so that the whole expression will be equal to 1/2 multiplied by 4x raised to 4 minus 5x squared plus 8x minus 12 divided by x minus 3/2. So by doing such, we have now rewritten the whole expression with a linear divisor whose leading coefficient is 1. We will now divide 4x raised to 4 minus 5x squared plus 8x minus 12 by a linear divisor x minus 3/2. So we will now identify and write the numerical coefficients of the dividend. Those are 4. There is a missing power of x, so I will write 0 as the numerical coefficient. Next is negative 5, positive 8, and negative 12. Then, we identify the value of a in the form x minus a. We can do that by equating x minus 3/2 by 0. So, by property of equality, we know that x must be positive 3/2. So, we have now the value of a as 3/2. Then, we can now proceed to synthetic division. We will now bring down the first numerical coefficient, that's 4, multiplied by 3/2. 4 multiplied by 3/2, that is 4 times 3 is equal to 12, divided by 2 is equal to 6. Then, find the sum of 0 and 6. That is, 0 plus 6 is 6. 6 times 3/2, that is the same as 6 times 3, that is 18, divided by 2 is 9. Or just simply find the common factor of 6 and 2. The common factor of 6 and 2 is 2. So 6 divided by 2 is 3, times 3 is 9. So we write now 9. Then find the sum of negative 5 and 9. Negative 5 plus 9 is equal to positive 4. Find the product of 4 and 3 halves. That is 4 times 3 halves. 4 times 3 is equal to 12 divided by 2 is 6. Or find the common factor of 4 and 2. The common factor of 4 and 2 is 2. So 4 divided by 2 is 2. 2 divided by 2 is 1. 2 times 3 is equal to 6. So 4 times 3 halves is 6. Then proceed to addition. 8 plus 6 is equal to 14. Then multiply 14 by 3 halves. 14 multiplied by 3 halves. There is a common factor between 14 and 2. That is 2. 14 divided by 2, that is 7. 2 divided by 2 is 1. 7 times 3 is equal to 21. So, this is 21. Negative 12 plus 21 is equal to 9. So, we have now the quotient of 4x raised to 4 minus 5x squared plus 8x minus 12 divided by x minus 3 halves. And that is 4x cubed plus 6x squared plus 4x plus 14 with a remainder of 9. We have now solved the quotient of 4x raised to 4 minus 5x squared plus 8x minus 12 and x minus 3 halves. And that is 4x cubed plus 6x squared plus 4x plus 14 plus the remainder 9 expressed as 9 over x minus 3 halves. That is to be multiplied by 1/2. Because, as you remember, we have written this original division sentence in a way that it will have a linear divisor whose leading coefficient is equal to 1. So, that is 1/2. 1/2 must be distributed to the whole polynomial. That is 1/2 multiplied by 4x cubed. That is 2x cubed. 1/2 multiplied by positive 6x squared. That is 3x squared. 1/2 multiplied by 4x. That is 2x. 1/2 multiplied by 14. That is 7. And 1/2 multiplied by 9 over x minus 3 halves. That is 9 over 2x minus 3. That is 1 times 9 is 9. 2 times x is 2x. 2 times negative 3 halves is equal to negative 3. So the remainder is 9 over 2x minus 3. So we have now the quotient as 2x cubed plus 3x squared plus 2x plus 7 plus 9 over 2x minus 3. That is exactly the same to the quotient of long division method. Did you learn something from this video? If so, don't forget to like, comment, share, and subscribe. This is Sir JC reminding you, math is easy when you perceive it positively.